Hi, my name is Zoe, and my lab partner is Brian. Today, we're going to talk about Gadovist synthesis. First, let's take a look at Gadovist's background. Gadovist, also known as Gadbutyl, is a gadolinium-based contrast agent used in conjunction with magnetic resonance imaging, which is also called MRI. Gadovist was developed by Schering AG, which was a research-centered German multinational pharmaceutical company. The key patent for Gadbutyl was granted to Schering AG at first. This patent covered the process of producing gadolinium complex using Gadovist. In 2006, Bayer Healthcare Pharmaceutical observed Schering AG, and the patent rights were transferred to Bayer Schering Pharma. Following that, Gadovist is the trade name for Gadbutyl and associated with Bayer. Gadovist was initially approved in Switzerland in 1998 for MRI scans of the brain and spinal cord. After that, it has gained approval in 65 other countries for various applications. In the United States, Gadovist became the first FDA-approved contrast agent for children under 2 years old. 2019 is a crucial moment for Gadovist. The FDA granted its approval for a new application, which is cardiac MR in adults with known or suspected coronary artery disease. This approval distinguished Gadovist as the first and only contrast agent for the specific use in cardiac MR. This decision was made based on extensive research involving nearly 1,000 adults, making Gadovist becomes an important tool in cardiac diagnostics. Gadovist, as a contrast agent with magnetic properties, can enhance the visibility of blood vessels, organs, and other non-bony tissues during MRI and magnetic resonance angiography examinations, aka MRA. For diagnostic applications, Gadovist can help diagnose disorders related to the brain, spine, heart, and blood vessels of the kidney. It is able to highlight disrupted regions of the brain and abnormal activities in the central nervous system. Gadovist is also valuable in breast MRI to help breast cancer detection. In addition, the dosage of Gadovist is precise to ensure the best imaging results are tailored to each individual. The standard dose of Gadovist is 0.1 ml per kilogram of body weight for both adults and pediatric patients. It is formulated at a higher concentration compared to some other gadolinium-based contrast agents, allowing for a lower dose to be administered. Gadovist is administered as an intravenous injection. After injection, a saline flush is used to ensure complete delivery of the contrast agent. Then, MRI scans can be started immediately.
Hello, this is the Gadovist reaction scheme. So what we have here is our starting material. It's a modified cyclin with formaldehyde, which serves as the protection group for the first step. What happens here is that the nitrogen will do a nucleophilic SN2 attack on the alpha carbonate, which will kick off the bromine. What also happens is that the water will take away the protons, and this will happen a total of 3 times, which gives us our first intermediate. In this case, the bond protecting group with an extra carbon will become the new protecting group, and there will be all 4 functional groups attached to the nitrogen will be hydrolyzed with water. The mechanism is carbonyl chemistry. Where there will be a proton transfer first from, in the case of the formaldehyde, the nitrogen will take the proton, ideally in solvent, so with the help of other water molecules. So water will take the hydrogen to become hydronium, and nitrogen will take the hydrogen away from hydronium. And this will make the nitrogen partially positive and allow the kickoff of the aldehyde group. And the same thing will happen here, except the water will attack the carbonyl and it will kick off the ester. So that gets us to the step when we'll get our stereochemistry for this drug. What happened here is that we'll react it with epoxide and ketone. The epoxide here has no stereochemistry because it is a methyl compound. And with the nature of epoxide, it will be thin, and the epoxide attack by the nitrogen will make the product naturally anti. So this will break open the epoxide ring, and the oxygen will protonate. What also happens here is that the ketone will be broken open, the ketone bond. So while the oxygen will be protonated by water, and it will be kicked off. And the intermediate step here will then proceed to be attacked by water. And this will kick off. There will be a proton transfer. Same thing as before, ideally was the solution. And it will, this whole part will be break off, will be kick off, and we'll get our product over here. So our product, as drawn here, will be an SS conformation, but ideally it should be in reality it should be a racemic mixture with also the RR conformation. The last step of our reaction scheme is the metallation of the gadolinium oxide. So what happens here is that once they're inside the container and they're heated, while the oxidation state of gadolinium is 3+ and oxygen should be 2-, which cancels out the charges. One of the gadolinium will pop inside the signaling ring, and the extra hydrogen will be kidnapped by the oxygen.